Okay, here's your lesson for P3. Polynomials and special products. Just kind of some of the basics of how we simplify and do some algebra with polynomials, which in a functions course you'll use a lot. They're a really common function for modeling purposes. They represent a lot of different situations really well. So you'll see them quite a bit. Not right away necessarily, but you'll see them. You'll see plenty. Okay? So a few things terminology-wise to get started. When we're talking about the degree, okay, I'm looking through here. This one isn't written in what we would call standard form. We'll get to that a little bit more at the bottom of this slide. We typically would like it all, actually we'll talk more about it now. That's the very next line. They should be in descending order by their powers. Okay, so if I were to switch this to standard form, it should start with 3x to the 7th. Minus 9x to the 4th. Plus 6x squared minus 2x plus 11. Okay? That's the order that we would like it in. Okay, you can actually fill this one in down here. Always write your answers in standard form, okay? Which again, write a note in there if you need to. I don't really have space, but that's descending order based on the powers, right? So I went 7, 4, 2, 1, and the constant would always go at the end, okay? The degree would be 7. That's just a fancy way of saying what's the highest power in the polynomial. In this case, it's 7. The leading term, there you would include the variable and the coefficient, which would be 3x to the 7th. The lead coefficient is just that number in front of the term with the highest power. That would just be 3, okay? Anytime you hear that term coefficient, that's talking about the numbers that are in front of the x's. Like 3, negative 9 would be a coefficient, 6, negative 2. Constant term is 11. The linear term, that's like right here. That's the term that's got the first power. That's negative 2x. The quadratic term, that's the squared one. That would be 6x squared. Cubic, that's the term with the third power. Doesn't have one, so we'll say none. Quartic is 4th degree, okay? 4th degree, so that would be negative 9x to the 4th. So there's a little vocab with all kind of the different parts of that polynomial, okay? We'll head down to the bottom here. Really, when you're talking simplifying, before we get into like doing a product or multiplying polynomials, it's really all about combining like terms, which sometimes can be a really simple process, okay? Depending on, like if you have a negative sign to distribute, you'll see on the second one here, I'll have to distribute this negative sign first. So this one will leave me with a little bit more to do than the first one. Right, this plus sign, there's nothing to do. So essentially in both sets of parentheses, I can just drop. Okay, that's like the first thing to check is can you just get rid of the parentheses, or do you have something to distribute? If it's just a +1 in front of it, you can just drop them. Okay, so the like terms that you would combine are based on the powers. Okay, so I see a 5x to the 3rd and an x to the 3rd. Those two could go together. I'm going to go right to standard form here because I can see there's no power higher than 3. For 2, I got a negative 7 and positive 2. I'll add those together. Negative 5x squared. first power, the first polynomial doesn't have one, right? This one does. There's a negative x, nothing to combine that with, so it just stays. And then negative 3 plus 8, well, that's 5. And there you go. Okay, once you've added them together and combined the like terms, you should notice that you don't have any repeats, right? I have one third power term, 1 second, 1 first, and a constant. Okay, but it's not like it was before when the two polynomials were being added that I had two cubic or third degree terms. All right, let's head over to this next one. I'm not going to rewrite the first part. I can just drop the parentheses, but over here, I got to multiply out this negative. So if I were to think of no parentheses around the second polynomial, it would have to be negative 3x to the fourth minus x to the third plus 4x squared minus 3x. Okay? Now, once that's gone, now it kind of just turns into the one before where I'm just looking for powers that are the same, right? I see two fourth powers, and notice again, I'm kind of like looking at both of them and thinking through, okay, what's the highest power? The highest I see is 4. Let's do those first, and then let's work our way down. So I have 4x to the fourth. I got a negative x to the third, nothing to combine that with, so it'll just stay. X squared, I got a negative 1 and a 4. Add those together, negative 1 plus 4 is 3. For the linear term, or first power, negative 4 minus 3, negative 7. And then that constant term doesn't have anything to combine with, so it's just 2, okay? So again, on that one, if you have stuff to distribute, to get rid of the parentheses, make sure to do that first. Here it wasn't too bad. It was just a negative sign in front of that second one, but be sure to do that. All right, we'll get to some multiplying here. Multiply some polynomials. Okay. I'm gonna scoot this over a little bit so I have some more room. All right, so these first 4, you've probably seen these before. These are the rule that we typically would call a FOIL, for first, outside, inside, last. So that would be like multiplying basically a line by another line, right? You would expect for these, you're probably going to get a quadratic for your answer, but it's multiplying two polynomials that each have 2 terms, okay? So here in this first one, I multiply the x's, and I get x squared. Then I do the outside, and I get minus 2x. Inside, plus 3x. And the outer, I get minus 6. All right? After you do that FOIL, be sure to look through and see, do you have any like terms to combine? Typically you will, not always, but most of these you will, especially on the middle 2. Negative 2 plus 3 is 1. So you have x squared plus x minus 6. Okay? X squared plus x minus 6. Now this next one kind of involves a special rule that I'm going to give you. I'm not going to give you all the special rules, but just a couple of them. This one is the difference of two squares. All right, so if you call these two terms like u and v, here's kind of the general rule for one that looks like this, that he had u plus v times u minus v. It would be u squared minus v squared, okay? So in this case, u would be like 5x and v would be 9, okay? But if you didn't catch that special rule, that's fine. And on a FOIL problem, you never really need to recognize that it's a special case. Just FOIL it. And if you FOIL it correctly, you're going to get to where you want to go. Of 25x squared minus 40x plus 40x minus 81. And this is where it kind of takes on that special case. So when you have the difference of two squares, you're going to see those middle two terms cancel out. And you would have 25x squared minus 81. Okay. So if you recognize that one, you could just jump to that 25x squared minus 81. All right, trying not to run out of room over here. Here we're multiplying the same term by itself. You have 4x squared. Now notice here with the two terms being plus, they don't cancel, right? They actually end up just getting doubled, that you would have 6x and 6x. If you wanted to think about like a rule for a shortcut, right? You notice those two are just the same terms. They combine into 12x plus 9, okay? Over here, you'll notice some similarities. Except you're just going to have a minus sign in between. So you'd have 36x squared as I multiply the first two. The outer minus 30x. The inner minus 30x, and the n plus 25, okay? But you see that same thing going on in here. Again, the only difference being you end up with a minus sign in front of that middle term, okay? So each of those, again, involve kind of doing a FOIL, but you're multiplying the same term by itself, okay? And over here, I'll take you through some cubics, which is a whole different deal. Here, it's really, really helpful to just know some of the special rules on this. So you've got a line in there, 3x plus 2, but notice it's to the third power and not the second. There, it's pretty important to just simply know the rule. Okay, because if you were to just say, oh, I'll treat it like a superfoil and like write out all three terms, you could do that. It would follow the same process. But as the power goes up, it can really turn into a mess really fast, okay? But what you have here is essentially this. The case is u plus v cubed, okay? And that case actually looks like this. You would have u cubed plus 3u squared times v to the first plus 3u to the first v squared plus v to the third, okay? So I'm going to take this approach and actually fill in the work right underneath there, and I'll give myself some more room. Okay, but basically the approach I'm taking is that 3x is u and 2 is v. So I'd say, all right, let's go 3x squared, excuse me, not squared, cubed, plus 3 times 3x cubed times 2, just to the first, plus 3 times 3x to the first times 2 squared plus 2 to the third. Okay, so literally that looks like a lot, but again, all that happened is u became 3x, v became 2, okay? Now I'll simplify these. This would be 27x to the third, because that third term applies to both. Just like in the second term, the squared applies to both. So 3 squared would be 9, times 3 would be 27, times 2 more. You'd have 54x squared. Let's see, here we'd have 4 on this third term. 4 times 3 times 3. That would be 36. And then 2 to the third power would be 8. Okay? A lot going on there. As we get closer to like assessments, I'll get you organized on like all these kind of special rules that you would want for foiling or distributing a polynomial. Okay? Now look at this one. Okay? Last one we'll do here. What I want you to notice here is if I were to group these two terms together, this is where the special cases can really come in handy. If I were to say, okay, you have x plus y, think of that as like a term together, minus 2, and then x plus y plus 2. I'm going back up to this rule right up here, and I'm thinking of this as u, and this is v, okay? Because this would be two polynomials with 3 terms. Again, you could treat it like a FOIL and distribute it. It just gets really long and it turns really messy, and if you wanted to do that, it would be fine. But you recognize the special case, and you're like, all right, when I look at it this way, that's u, and that's v, it really looks like the left side of that special case, u plus v times u minus v. So I could rewrite it like this and just say, all right, that would be equal to u, which I said is x plus y, squared minus v, which is 2 squared. And once I've done that, this turns into a much simpler case, as I now just have to FOIL a 2 by 2, and I'll have a minus 4 at the end. So this would turn into, let's see, x squared. Outer term would be x times y. Inner term would be x times y plus y squared minus 4. We'd have 2 terms in the middle to combine, and we'd have x squared plus 2xy plus y squared minus 4, okay? Again, a little bit trickier there. That polynomial has got 3 terms. You'd really have to apply that special case with the difference of 2 squares. But yeah, that's about as tricky as we'll get to give you kind of something that goes beyond multiplying a polynomial with 2 terms by another one with 2 terms. Usually it would involve just kind of like the one to the left, where you just had to know that rule that you've got in your notes now for something raised to the 3rd power, or if it's a little tricky like this one, somehow involves applying one of the rules.